Here, I'm going to present the summary of the paper. Plant responses to nitrogen fertilization differ between post-mined and original peatlands. The study was conducted by Aiko Nishimura and Shiro Tsuyuzaki, Graduate School of Environmental Science, Hokkaido University. Now the study at a glance. In this study, the effects of nitrogen accumulation on plant communities of post-mined peatland and original peatland was examined. Nitrogen addition did not influence plant communities at the post-mined sites, but it negatively influenced plants at the unmined site. It can downturn native mosses and forbs, giving dominance to invasive grasses. Now, the materials and methods that were used for this study. The study was conducted in Sarobetsumayor, situated in northern Hokkaido, Japan, and it was studied for 3 years from 2005 to 2007. 3 sites were selected to represent post-mined sites. They are Moliniopsis japonica grassland, MJ to be abbreviated, Rhynchospora albaces land, RA, bare ground, BZ, and a surrounding unmined bog, SS, which is predominated by sphagnum. 5 different nitrogen concentrations were applied in the plots. The concentrations are 0.0, 4.5, 9.0, 18.0, and 36.0 gram nitrogen per square meter. Effects of these treatments were measured with different statistical analyses, for example, analysis of variance and 2K post-hoc taste. In this figure, we find the changes in plant cover, species richness per plot, and diversity. Here, in busy plot, we find there is a statistically significant changes in diversity throughout the years. In RA site, plant cover differs significantly between the years, and there is no changes in species richness and diversity. In MJ plot, the diversity, species richness, and plant cover don't show any changes. Lastly, the SS plot displayed significant differences in species richness and diversity. In this figure, the above ground biomass of 4 vegetation types, forb, moss, grass, and shrub, is shown. In all the plots, we find that there are different responses of the vegetation species. Remarkably, we noticed that in SS plot, grass biomass increases significantly, while forb biomass and moss biomass decreased, and the biomass were decreased to nearly 0. Then shrub biomass shows a significant increase in its biomass in the concentration of 18 gram per square meter per year, but with the highest concentration, the biomass decreased the lowest. Now the nitrogen standing stocks in 5 plant species: C. middendorfi, R. alba, P. communis, M. japonica, and sphagnum. There is a significant decrease in nitrogen standing stock in sphagnum, in MJ plot, and the unmined SS plot. Nitrogen content in M. japonica increases in the original peatland, and it is noticeable that M. japonica was not the dominant species in this plot. arable biomass decreased with nitrogen addition throughout the years, and it is observed in RA plot. So to conclude, we can say that high nitrogen was detrimental to original bog species, sphagnum mosses in this study, while it was good for invasive grass species like P. communis. Nitrogen enrichment controls the succession of early to late colonizers. This study also shows that for revegetating the original species and to conserve the original peatland, nitrogen addition in the sites should be avoided. Thank you.